All right, guys, let's go through the next set of reactions we're going to be looking at. And thankfully, we're going to be looking at combustion. We've done combustion before, so it's all really similar, but we just need to recap it so you guys know that it is its own separate topic as well. So with combustion, where we're going to be reacting with oxygen in two different situations. One is complete combustion, where it is going to be producing CO2, and that is in a plentiful supply of oxygen, or in excess oxygen. And then we have incomplete combustion, which I don't think we've covered in the last few videos, but in this time, we're going to produce carbon monoxide, so that's CO. There are some variations to this where you might also produce just carbon on its own, and then you need to kind of balance it slightly differently, but the process will still work for you. More often than not, it might be a gap fill, and you have to fill in the blanks. Task I've got for you is just to recap combustion in its form of complete and incomplete, and obviously one with an alcohol. We're still going to use the same technique as before, so C, balance all of the carbons, then balance all the hydrogens, then check your oxygens, and then divide it by 2. And that's going to be the trick. If you're unsure, I would go back to the combustion video and have another go at that. For butanol, we're going to do the same thing again, but this time remember for alcohols, when you've counted up that final oxygen value, so let's say, for example, you might be on, say, 9, because we've got an alcohol that has an O in it, we're going to deduct 1, so it'll be 8, and then we do 8 divided by 2. That'll make more sense when you actually go to balance it. But in the meantime, have a go at those combustion questions and refresh your memory. Right. This time we're going to move on to something slightly different, and it feels a bit odd, but this is a type of reaction. It's called alkane cracking. I'm going to give you some of the concepts behind it, but if you hear of any type of cracking, and when you're looking at a large chain alkane, there are only two variations or two kind of rules you need to pay attention to. Number one is thermal cracking. You can read the information here, and I do advise it because these are the things they can ask you in detail to explain. But I just want to show you the trick of how to do the equations. So for thermal cracking, we're going to use high temperatures, and it's going to split the molecule toward the end. So you can see here I've got C10, and what we're going to do is we're going to break it right toward the end portion. And the end portion is kind of ambiguous. You know, it could be here, it could be here, it could be here, but it's towards the end. It certainly wouldn't be in the middle, more often than not. So for thermal cracking, it favors chipping it off at the ends. So imagine like it's heating it up and it snaps it and frays it off at the very, very end. The other cracking we have is a catalytic cracking. And for this, we use a zeolite catalyst, just a term you'll need to remember, and then lower temperatures. For this, the chain breaks more centrally. So you're basically going to try and find the midway point and then split it. When you're doing any form of cracking, the products will always add up to what you started off with. It's simple balancing, but the easiest way for us to do this is imagine it like Lego blocks. On this side, we've got 10 Lego blocks. I break off 2 of them, and therefore I make a C8H18. I also make a C2H4. And to double check that, you can add up the hydrogens, and they will also add up to the ones in our reactant. So there's nothing lost. You can track it all quite easily. The general formula will also help remind you, is this an alkene or is this an alkane? Remember, alkanes, CnH2n plus 2, double it, add 2. And for double bonds, we double the C. So here, you can see 2 of them, double it, you get 4. This could be the other way around. So you could have a C8H16 and a C2H6, and that's fine as well. But at the end of the day, we just need to break it at the end. What I've got for you guys to put this into practice is a couple of examples here, and I think it would be good if I can give you some form of help with this. So let's take decane, for example. Decane, you've not been taught, but it is 10 carbons long. So I'm just going to draw 10 carbons over here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we're going to crack it. The first example says thermal, and in the thermal, they're actually giving you the products. Well, I'm giving you the products. We've got a propene and a heptane. So let's draw our heptane first. Heptane is 7, so I'm going to go 1, 2, 3, 4, 5, 6, 7, plus my propene. Propene, 3 carbons, and a double bond. So I'm going to go 1, 2, and 3, and then I'm going to add a double bond. You can add it on the other side as well, and that's fine. What I would like you to do is to write down the balanced molecular formula for the reaction above. For catalytic, I'm going to do the opposite for you. So we got pentane and pentene, and we're cracking decene. So what I've got is I've got C10, H22. We're going to add a zeolite catalyst to this, and we're going to try and split it in half as evenly as possible. So I'm going to have pentane, which is 5. So I'm going to go C5. Pentane is an alkane, so double it, add 2. It's H12. Plus my pentene, which is C5, H10. I just wrote 10, I don't know why. H10. And then for this, what I would like you guys to do is I would like you to draw the skeletal formula above this one. I appreciate I probably didn't give you that much space. Maybe I can do that in the next time I make the booklet again. But give you a bit more space. For octane, this is C8H18, and I would like you guys to do both of these. I've also given you a bit of more freedom in terms of to work out what's going to be produced. So you're going to have to use a balanced equation to determine what's going to be left over. Remember, the products will always add up to the reactants, and you'll always have an alkene and an alkane, either way around. In this one, I've already give you the alkane, so you need to determine the alkene. And then for catalytic, I've left it completely open, so therefore you need to come up with a valid solution for that one. That's cracking in a nutshell. That sounds like a pun. I'm going to leave it there, and I'll see you guys in this video.